Hello and welcome back to another tutorial. This is the 6th of the AutoCAD challenges, and I figured I might as well skip the other two. They're pretty basic concepts, so we're going to do this a little bit more complex part here, and I'm going to do it live. So with that, let's get to it. Okay, we're going to start this out by, in this default work plane, just sketching a rectangle here. Okay, and we will go back here, and that's 25 millimeters by 15. 25, oh, this is in inches, so let's change that first. 25, there we go, by 15. Okay, then we're going to use the tangent tool. This is pretty much the only context that I like to. You can also press Shift A, and that will get in the way. That I like to use these automatic fillets in SolveSpace is when it's clearly on the edge of a part. I've just had issues otherwise. Okay, so we got those fillets in place. Let's see what they are. Radius of 1, which means a diameter of 2.0. Okay. Go in here. We've got 0 degrees of freedom. Beautiful. Extrude. That is far too much. This bad boy is 6 millimeters. Alright. We're moving along nicely. Okay. Next, we'll put in these 4 holes here. Those are easy enough to do. So we'll zoom in here. Point, line. Sorry, line, point, line. Shift W. Zoom out. Press C for circle. Make them any size we want. Those vertical, these horizontal, and these vertical. Then let's make them equal. And then we'll go ahead and dimension these. I remember from the page that they're 3 millimeter diameter. And I don't remember their spacing. 9 apart. Okay. Oops. 9.0. And then 19 this direction. 9.0. I apologize. Let me let that clear out on that screen. Okay, let's go back. And there are 3 from the edge in all directions. Okay, so that dimension is, oops, 3.0. This dimension here is 3.0. And we're fully defined. Okay. We will go ahead and extrude those. Say difference. Select that point. And select that face, not that. I apologize. There you go. Press O, and then we'll move in here. We'll make this shape here, which is 16 millimeters here, which is made by an arc, and 2 line segments. Okay, and we'll just put it real quick, that in place. Oops, that in place. Ooh, didn't want that. That, and that. Now that'll change in a minute here, but it's okay for the getting started. Okay, so this is a diameter of 8. equal. Okay, the red background tells us that it's over constrained. So we'll just Control Z that. And then, let's see here. 3.5 to this edge, 5. Then we need another arc here. And we gotta do this guy that splits it. Oh. Put it back, that, and we will go ahead and split that. Now, the reason we gotta split that one is because actually we can just make this line horizontal. The reason we have to split that is because we need to be able to make this green, or make it a construction line, because otherwise you would just have a solid line there. So with that intersection gone, we can go ahead and make this 1.5, which means a diameter of 3. And, oh, sorry, I gotta let this clear again. Apologize. Make that halfway through. That's a mid-plane, so we'll do this. Make that and that on each other, and this here. M for midplane, or midpoint, it automatically, when you press M, a point in a line segment, it will automatically constrain that point to the center of that line. That will constrain that vertical. Also make that a construction line. Okay, and then we should have just 2 more degrees of freedom. Okay, so the length here, which we do know as 16 overall, which is really 16, if we want to do these centers here, it's 16 minus 1 diameter, which is 8. And then, let's see, what else do we need to constrain? Location. So how we could do that is S, this point here to that point there. Oops, got a little carried away. Midpoint. Oops. Okay. Oops. Did not mean to do that. Vertical here. Make that a construction line. And so this and that. Midpoint. There we go. Alright, 0 degrees of freedom. So we're good to extrude this part. We can go ahead and hit difference. And we will select this point, or that line there, and dimension it. And it goes 3 millimeters down. There we go. We got that pocket. Okie doke. Now, oh, another way that you could do this is to make this slot here, and this is if you were machining it, how you would do this. But you would make this slot, and then you would go in and drill a hole here, or drill a hole and then make this slot. But since we're designing it, we can make it however we want. And so I put the feature in there to begin with, but that's not necessarily how it would go in the real world. Okay, and then let's see here. Let's put in this 4 millimeter point there. You can just select that and hit Shift W. And it's right on that. See the diameter of 4.0. Okay, and that's 0 degrees of freedom. We'll extrude that. That's going to be a difference. 4.5 millimeter. Nope. 4.5 from the top. So it's really only down 1.5. Okay. Perfect. Now we need either this feature here or this hole here, and we'll be done. So let's go ahead and, well, there's a couple ways we could do this. We could, let's cheat, shall we? Let's just cheat. Normally, if you were manufacturing this part, you'd have to bore this out from the backside there, but again, since we're using CAD, we can go ahead and model it however we like. So this circle here, oh, and there, okay. All right. So we know that's a 5mm diameter. Sorry, I was trying to figure out the projection of it and realized I didn't know for sure. So I wasn't going to say it. I was going to say I think they're using the wrong projection for American manufacturing, which is third angle projection, but I'm not confident enough on that, so I'm just going to move on. All right, so we can put that 5mm bore in right here, and this doesn't particularly matter. Now, a lot of people are like probably thinking that with SolveSpace you don't have a hole generating tool, and that is completely true. However, you can still do some pretty complicated stuff. In tutorial number 2, I showed how to make a counter bore, but this model here, actually, I think, I'm pretty certain this is the incorrect projection for an American drawing, but again, nevertheless, or actually it's a section view, so maybe it's okay. Regardless, it doesn't matter. So moving on, we can go in and we can put in this feature here, and I want to do a full model of this part, not anything cheating. So what I'll do is sketch on this, after I said I was going to cheat this whole time, I know. So I'm going to sketch on that work plane. That's a mid plane on this part by selecting a line, point, line. And then I'm going to turn on hidden lines. Now, this might make it kind of confusing or difficult to make full understanding of, but I've found that it's pretty easy to go ahead and just rough out the shape that you want outside the feature. And we'll go ahead and make these vertical, horizontal, vertical, horizontal, horizontal. Okay, and then let's see, what's the counterbore depth there is 1.5 millimeters, and then to this point is 3.0. Apologize again. I'm looking for another keyboard display program, but haven't quite found one that I like yet. Okay, and then we'll do this. Generally speaking, there's 60 degrees, or yeah, 60 degrees, that looks about right. And then this diameter here will be 2.5. And that bore here will be 1.5. Okay, now it's only this, it's only got 2 degrees of freedom here, so we know that it's the 2 in this plane. Oh, I managed to screw that up. Okay, and now all we need to do is constrain that point to that point. And we've got 0 degrees of freedom. And then what we can do is select that point and that hidden line there and do a revolve difference And you've got that counterbore. And now we'll go ahead and remove the hidden lines there. And we've got the counterbore drill bit there with the semicircle hole. And there you go. That was a live tutorial for you guys. Let's go ahead and finish this up by going to a good isometric view. I'll match the one here in the drawing. I'll hit tab to hide that guy. And I gotta hit this real quick. Tab to bring that back up. Hide all. There we go. Close. And there you go. The pump housing. This is a relatively more difficult part than what I've shown before, but even in a very basic modeler like SolveSpace, you can still accomplish pretty difficult models. So, thanks for watching.